Hello,
Hello.
can you hear me?
Hello.
But your voice
Yeah.
is very faint. You have to speak up a little bit.
Better?
Yeah,
Better?
slightly better now. Okay. So today we'll begin. We have already done it a little bit, but we'll go into more depth now and we'll look at quadratic functions. Okay.
Right.
So we have already seen f of x is equal to ax squared plus bx plus c. This is a quadratic function. When I say function, you know what that means? Basically, what that means is when you say y is equal to something in terms of x, that is a function where x is input and y is output. So when I say a quadratic function, here y is equal to ax squared plus bx plus c, you can give different values of x and you will get different outputs of y. Are you understanding what I'm saying? So a function is like a machine that takes an input and gives out some outputs. So right now we are talking about quadratic functions, and we have seen earlier that this type of function has a graph that is like a parabola. There are three versions of the graph. You could have a graph like this, you could have a graph like this, or you could have a graph like this. If a is greater than 0, these are the three different types of graphs possible, right? And always this horizontal line that I'm talking about is x-axis. So this is the kind of graph where there are two roots, 2 points where the graph is becoming equal to 0. These roots are alpha and beta. And here the discriminant should be greater than 0. And discriminant is what? Discriminant is b square minus 4ac. Do you remember we have discussed all this? This graph is the graph where the quadratic function is always positive. So discriminant is less than 0, or b square minus 4ac is less than 0 here. And this graph is when discriminant is equal to 0 and it is touching the x-axis. So both the roots are going to be equal here. Alpha and beta, the two roots are equal and the graph touches the x-axis. Obviously, these are not the only ways you can draw the graph of a quadratic function. There are three alternative ways where a is less than 0. In that case, the graph looks like this downward. I hope you are understanding what I'm saying. So basically, that is the first thing that you need to remember. The next point that I want to talk about is when you look at the graph, f of x is equal to ax squared plus bx plus c, the point that is the vertex is always known to us. Either it can be like this or it can be like this. This point is known to us. This point always happens at x is equal to minus b by 2a. Here also x is equal to minus b by 2a. And this is known as the vertex of the graph. So this is the case where a is positive. This is the case where a is negative. And in both cases, you should realize that at x is equal to minus b by 2a, f of x will be minima or maxima. What do I mean by minima or maxima? It means the value of f of x will be either the lowest value or the highest value in that quadratic. It depends on whether a is positive or a is negative, right? Is it clear what I'm saying?
Yeah.
Okay. Also notice that the graph is decreasing and then increasing. That's why it takes a minimum value at this point. So f of x was decreasing, values of f of x were decreasing and then increasing. And similarly here they were increasing and then decreasing. That's why it takes a maximum value in this graph. One thing to realize is that the quadratic function is symmetric about its vertex. About its vertex. What do I mean by symmetric? What I mean is like this vertex is like literally dividing the graph into two equal and identical parts. This part of the function is the same as this part of the function. It's like a reflection.
Yeah.
So that has interesting implications. So for example, if I say like this is my graph of a quadratic, and this is the point x is equal to minus b by 2a. If I go to a point somewhere here where x is equal to minus b by 2a plus some c, and if I go some point here where x is equal to minus b by 2a minus some c, at both places the y value will be same. Do you understand? Any point on the graph can be written in terms of the coordinates x comma y and x comma y, right? What we are saying is that since this is the point where the symmetry happens, if you go equal distance to the right and equal distance to the left from this point, the y coordinate remains same. That's the meaning of saying that they are reflected.
Right.
So basically what we can say is f of minus b by 2a plus c is same as f of minus b by 2a minus c if f(x) is a quadratic. If f of x is a quadratic, then always when I say f of x, f of this, I'm saying what is the output when you put input as this. When you put x is equal to minus b by 2a plus c, what is the y value? Similarly, what is the y value here? Both the y values have to match. So this point is like minus b by 2a minus c comma y, and this point is minus b by 2a plus c comma y. The two y values are same, even though the x coordinates are different. I hope you are understanding what I'm saying.
Yeah.
Okay, so that is one important thing to know. Then I think we have discussed things about roots and all. So I'll just quickly revise that. So if f of x is equal to ax squared plus bx plus c, we can write this as a times x minus alpha, x minus beta, where alpha and beta are roots of the equation ax squared plus bx plus c equals to 0. How do I know that this function can be written in this factorized form? I know this because if I multiply it out, check it out what happens when we multiply it. It becomes x squared minus alpha x minus beta x plus alpha beta. And that can be written as a times x squared minus alpha plus beta into x plus alpha beta. And we learned earlier that once we know the equation by Vieta's relation, alpha plus beta must be minus b over a and alpha beta must be c over a, right? Here alpha beta are the roots. We know this works always. This is always true, right?
Yeah.
So if that is true, we can put that in this place and see what comes here. It will become a times x squared minus, for alpha plus beta, I will put minus b by a times x. And for alpha beta, I'll put c by a, right? And see that if I multiply the a inside, this is becoming same as ax squared plus bx plus c. Can you see that this is multiplying and becoming the same thing?
Yeah.
So this is identical to this. So therefore, we can always write a quadratic equation or function in terms of its roots like this. A times x minus first root times x minus second root. And the reason it works is because of Vieta's relations that we already know. I hope you remember we had discussed this earlier.
Yeah, I know this part.
Okay, fine. So now what we will do is we'll start getting into problems and start discussing different types of situations and understanding it in a more deeper level. Also, by the way, have you bought the book, which is this book, Test of Mathematics at 10 plus 2 level?
Mm.
I had mentioned this book.
Yeah, I know, but I thought that you said we'll finish all the algebra and all, and then trig will come on later, so
This is
not
not trigonometry.
immediately.
You need to get this book. There were
Okay, I'll
several other
order
books.
it.
There were several other books that are maybe we can wait, but you need to get this book for practice. This is all the chapters, it will have practice questions. So the sooner you get it, the sooner we can do practice from that book. Okay.
Got it, I'll get it.
Yes, right now your voice is audible. I don't know what you were doing before. Earlier I could have hardly hear you. Right now you're closer or something.
Nothing, I'm sitting in the same spot. My
But now it
internet
is
is a bit unstable actually.
no,
It's
but now the
raining.
audio is completely clear. This is how it should be. Earlier it was like super faint. I don't know what was on with that audio. But anyway, okay. So get that book at least out of the 5, 6 books. That is first and that is urgent. Okay. Because we can do
Okay,
homework from there. We can do practice from there. Okay.
got it.
Okay. So first question that we look at today is this one. Suppose f of x is equal to x square plus ax plus b, and f of 0 is greater than 1, and they have given you f of 4b minus a is equal to f of 3 minus a square. You have to find the minimum value of f of x. Minimum value of f of x. By the way, whenever somebody says f of something, it's like saying you have put in this input for x into the function,
So
right?
X.
Yeah.
Okay, yeah.
In place of x, you can put in this, and in place of x, you can put in this. That's the
And
meaning
then
of
equate both of them.
right. But that will make it super long. So ideally, you should think about it a little bit. Maybe we can do it in a faster way. Don't do the brute force method. Do you understand what I'm saying?
I think.
Basically, don't put it directly into it and try to simplify everything and see. That to anybody can try, right?
Yeah.
What we need to do is do something clever and think about the function and then figure it out. Maybe without avoiding trying to put it directly into it.
Okay.
Hmm. See, this is my graph of my function, let's say. What is one way in which f of something can be equal to f of something else? One way is that
Sorry.
x1 is equal to x2, right?
Yeah.
Correct. That is obvious way in which they could have been equal, no?
Yeah.
So that is one way. The second way is if the graph is a quadratic and this is a quadratic, right?
Yeah.
The second way is that the points are same distance away from the vertex as both of the points are equal distance away from the vertex, no?
Yeah.
That is the second way for a quadratic to have same y value, right? We just saw that.
Yeah.
So basically, that would mean that one of the points is minus b by 2a plus something, and the other point is minus b by 2a minus something, right? Correct?
Uh, yeah, okay, yeah.
Then only no, the y values will be equal, right?
Yeah.
So in that case, we can say that if this is x1 and this is x2, and those are minus b by 2a plus c, and this is minus b by 2a minus c, in that case we can say that x1 plus x2 will be equal to minus b by 2a plus c minus b by 2a minus c. When you add them, you get simply minus b by a, right? Correct?
Got it.
So what we need to check here is perhaps this is a case where it is equal because of case 1 or it is equal because of case 2. We don't know yet, right? It could be
How do
that
we not know? I mean, it has to be this, right? Like, how else will they both be equal?
we don't know which one it is, no? Whether the inputs are only equal to each other, it could be that, right?
Okay. Oh, okay. So the inputs are equal to each other only when like it starts from zero, the symmetry line.
No, I'm not. That is not the symmetry argument. That's the argument that I don't know the values of a and b. Maybe 4b minus a is equal to 3 minus a square.
Yeah,
If 4b minus a is equal to 3 minus a square, you don't have to think of symmetry. No, the inputs only are equal.
right,
Then obviously f of x1 will be f of x2 if both x1 and x2 are same, right?
right.
So that is case 1. Case 1 doesn't have to do with symmetry. Case 1 has to do with inputs. Are they equal or are they different? Right?
Yeah. Case two will always apply, no? Like both are, it has to always be like equal distance from the vertex.
If the inputs are not the same, then always it has to be like this, right?
If the inputs are same, then also it will be that way.
If the inputs are same, are there 2 points or just a single point? If the inputs
Oh,
are same, x1 and x2 are the same, then there is no point of doing these 2 points.
right. Yeah,
We don't know what is the situation. No, we don't know what is B, what is A. We are just trying to figure out, right?
right,
That's why we are doing two cases. One case is when the inputs themselves 4B minus A itself is equal to this, right? Then there is only 1 point. No, there's no 2 points. Correct?
right. Yeah,
The other case is always true. If there are two separate points, then they can never have output same unless they are symmetrical from the vertex, right?
right.
So that is how we analyze it. So first we'll think about case 1, okay? And is it possible for the inputs to be same? F of x is x squared plus ax plus b. They had said f of 0 is greater than 1. They have said f of 4b minus a is equal to f of 3 minus a square. And here we are first going to analyze whether 4b minus a is equal to 3 minus a square, right? This is case 1. Do you understand?
Yeah.
So let's think about it. We have 4b is equal to 3 plus a minus a square, right? And b is equal to 3 by 4 plus a by 4 minus a square by 4, correct?
Right.
Now, if we look at this, we are getting b in terms of a, and this side, this right hand side here is a quadratic, right, in a, correct?
Right.
Now, what is this information? This information tells us what? That f of 0 is always bigger than 1, right?
Hmm.
What is f of 0? Can you see? F of 0 is what? Is b, no?
B. Yeah,
So
B.
this information tells us that b is bigger than 1, correct?
Yeah.
And here b is equal to something in a, right? Right.
Right.
So here we will use our understanding of completing the square method. We have done that many times before. So what I'm going to do is make a perfect square using the a square and a terms here, okay?
Right.
So think about it. There is a negative sign here. So maybe I should do 3 by 4 minus and then put a square by 4 minus a by 4 inside, okay?
Yeah.
It's the same thing as before. Nothing has changed. Now, this thing we will change. This thing will try to make a perfect square. So a square by 4, that is clearly a by 2 whole square, minus 2 times a by 2, and I need a second term, but notice that I have a by 4 here, and right now I have only a here, right? So the second term must be 1 by 4, no?
Yeah.
Do you understand? I'm trying to do a square minus 2ab plus b square, right?
Yeah.
So here I already have a by 2 square minus 2 times a by 2 times 1 by 4, but there is nothing else after that. So I will put a plus 1 by 4 square, okay?
Yeah.
And since I have added it myself, I have to also subtract it,
Subtract it also. Yeah.
right? So now you can see that this expression is a by 2 minus 1 by
Minus
4
1 by 4.
whole square minus 1 by
Minus 1
16.
by 4. Okay. Yeah.
1 by 4 square, right?
Yeah. Yeah.
So notice that this is my analysis of the stuff that is inside the graph, inside the bracket, right here,
Right.
correct? So I can now take it out of the bracket and I will get something like this. I will say b is equal to 3 by 4 minus, it is a by 2 minus 1 by 4 whole square minus 1 by 16, right? Correct? I have just
Yeah.
replaced this as this, nothing major I have done. So I will get b is equal
Yeah.
to 3 by 4 plus 1 by 16 minus a by 2 minus 1 by 4 whole square, right? Do you understand? I have just taken it out of the bracket.
Right.
Now, if you add these two, you will get 12 by 16 plus 1 by 16. So 13 by 16 minus a by 2 minus 1 by 4 whole square, correct?
Right.
Now, what does this tell us? B is equal to this expression. This expression is better to think about because perfect square is always going to be positive, right? this a by 2 minus 1 by 4 whole square is always greater than 0, correct?
Right.
Or equal to 0, but can never be negative, right? Do
So
you
your
real?
voice cut off.
So what I'm saying is, can you hear me right now?
Yeah.
So what I'm saying is that this square term is always greater than equal to 0.
Yeah.
So we are always going to have something like this. B is equal to 13 by 6 minus something that is greater than equal to 0, right?
Yeah.
So clearly that, so 13 by 16. So clearly that tells us that B is going to be lesser than equal to 13 by 16, right?
Why?
Think about it. If you subtract something positive from 13 by 16, isn't it going to be smaller than 13 by 16?
Oh, right. Okay.
Isn't that obvious?
Yeah, my bad.
So B is 13 by 16 minus something. So therefore it is less than equal to 13 by 16, correct?
Right.
But what did I get earlier from here? B was greater than 1, no?
Yeah.
So isn't that a contradiction? Direct contradiction.
So it's case two.
So basically we have realized that in case 1, we get B value to be less than something which is also already less than 1, right?
Yeah.
But that is not allowed. So case 1 leads to a contradiction. So it's case 2. Case 2 is the case when the inputs were not equal to each other, but they were symmetric about the vertex, right? Do you understand why we have figured out that case 1 is not possible?
Yeah, because like B was supposed to be greater than 1, but
Uh,
now we got B as less than this.
do you realize how we got B as less than 1 from this?
Yeah.
We wrote 4B in terms of A, and then we did completing the square on that A quadratic, right?
Right.
And once you do that, a little bit of arrangement and all, and you can see that it is 13 by 16 minus something, right?
Right. We can go
Okay, so now we can move on without any worries to case 2, and we know these things. We know f of 4b minus a is equal to f of 3 minus a square. But this time we know that these inputs cannot be equal to each other. They must be the 2 points which are symmetric with the vertex, right? Correct?
Right.
So this point must be minus b by 2a minus something, and this point must be minus b by 2a plus the same thing, right? Correct, no?
Right. Yeah.
So
We
in
just did this.
we just did this. So in that case, we know that when you add the two terms, x1 plus x2, the two inputs, if I add, it adds up to minus b by a, right?
Right.
So now we'll just add these two, and notice that so far when I'm using minus b by 2a and all, I am using it for a general quadratic like ax squared plus bx plus c, right? Because
Yeah.
for that we had this rule, no? So, but here the quadratic is slightly different. So don't get mixed up in that. Do you understand what I'm saying?
Yeah.
In R quadratic, this a part is 1, right? So let's just put minus b by a for R quadratic is what? Actually, the b term is the a term, right, for us? Do you see that?
Yeah.
So minus b by a is minus a by 1, right?
Right.
I hope you understand how I have written it like this, right?
Yeah.
Okay, so our input values should add up to minus a, correct? Is there some confusion here, Soroja?
No.
I thought I heard your dad in the background explaining this A and B.
No, he's talking to someone. He's on call.
Okay. Okay. If this is clear, then are you sure this is clear? No, how minus A?
Yeah.
Okay. So then we can add the inputs now, right? And say that 4b minus A plus 3 minus A square must be equal to minus A,
Right.
right? Great. So
Yeah.
then what we are getting is from here, minus A will get cancelled and we are getting 4b plus 3 is equal to A square, right?
Right.
Okay, 4b plus 3 is equal to A square. And that means that 4b minus A square is equal to minus 3. Okay, fine. Now we just need to find the minimum value of this function, right?
As in?
What?
As in, like,
That was the question. That was the question. The
yeah,
question was only
how
asking us to find minimum value of this function.
yeah, how do we do that?
It's very easy because we already know that will happen at the vertex, no?
Okay, yeah.
Minimum or
So,
maximum always happens at the vertex, correct?
right.
So we will say, so far whatever we have done here has given us one new information. This is the new information we got, right?
Right.
Now we come back to our original function and try to find the minimum value. Vertex is at x is equal to minus b by 2a. But in this problem, minus b is what? Minus a by 2 into a is 1, right?
Right.
So the minimum happens at x is equal to minus a by 2, correct?
Correct.
Let's find the value of f of minus a by 2. What is the y value at that point, right? So we put minus a by 2 for everywhere there is x, we get minus a by 2
Upon 4. Okay.
plus a into minus a by 2 and plus b, right? So it is
Yeah.
becoming a square upon 4 minus a square upon 2 plus b.
Yeah.
And notice that this is clearly minus a square upon 4 plus b, right?
Right.
This is the minimum value of the function. And now you will realize why the condition was useful. Because if you divide by 4 on both sides here, you are getting b minus a square by 4 is equal to minus 3 by 4, right?
Right.
Isn't that what we need to find here?
Yeah.
Minus 3 by 4 is equal to the minimum value.
Mm-hmm.
See, nothing very difficult was done. It was just a matter of understanding the graph of the function and equating the condition that if f of x1 is equal to f of x2, then x1 plus x2 should be equal to minus b by a, right? The x1 and x2 in our case were 4b minus a and 3 minus a square, correct?
Right.
And when we did all that, we got b minus a square by 4 is equal to minus 3 by 4 as our condition. And when we actually found the value of the function f of x at x is equal to minus b by 2a, we got something like this only was coming, right? That is supposed to be the
Right.
minimum value. Are you understanding the whole thing, what we did so far?
Yeah.
Okay. So that was the first problem. I will give you some time to think about the second one. Try it out. Uh, I will just tell you what it is.
Yeah.
1 second. Okay. Suppose the graph of y is equal to x square minus k minus 1x minus k minus 1 intersects the x-axis at 2 points A and B, and the vertex is at C. Find the minimum area of triangle ABC. Do you understand the problem itself?
I think.
You should not be so unsure. The graph is like this. It intersects x-axis at 2 points A and B. Where should I put A and B? These 2 points, right?
Yeah.
And the vertex of the graph is at C. So C is somewhere here.
Yeah.
And we can clearly see that they can form a triangle if you want to join them, right?
Yeah.
So the question is asking you, on this graph, on these points A, B, C, find the area of the triangle and find the minimum possible value of that area. In order to find the minimum possible value, you will have to get an expression for area of triangle ABC. Expression for triangle ABC area. Only when you have the expression, you can think about how can this be minimum. Do you understand?
So can we like just thinking out loud,
Hmm.
can we find like A and B like as zero, put zero in Y and then find
Huh.
A and B point, and vertex will be minus B upon 2, that thing.
So, you can. These 2 points are the roots of the quadratic, no? So that is
Yeah.
how you find them. But remember
Yeah.
that if you do it like that, then you will get a big quadratic with very complicated stuff, by the way, right?
Right.
You will
So
get 0
what
is
other
equal to
way
this.
was there?
Huh?
What other way is there then?
There are other ways. You can say this is some alpha comma 0 and this is a beta comma 0, right?
Right.
And I don't want to solve the question for you. You think about it. You know Vieta's relations also, no?
Yeah.
If alpha and beta are the roots and they are the roots, you already know alpha plus beta and alpha into beta, right? Do you understand what I'm saying right now?
Yeah.
You don't have to find them by solving the equation. If you put 0 and put it like that, you will get a very big complicated expression for which involves a lot of k's and square roots and all, right?
Yeah.
So try it out. That is an approach. If you have no other way, then you can do that also. But ultimately, remember, you have to find area of the triangle, right? So For area of the triangle, what do we need? We need this
Sorry?
length. Can you hear me right now?
Yeah.
Hello? Can you hear
Yeah.
me? So what I'm saying is ultimately you have to find area of the
Yeah.
triangle,
Yeah.
right?
I can.
Right. It is lagging a little, I think. So what I'm saying is, in order to find area of the triangle, you need the length of the base and the height, right?
So I'm so sorry. Can you like repeat once more? My net is really bad today.
I will say again, but again your voice has gone down very low again.
Now.
Yeah, it is slightly better, but still worse than what it was 2, 3 minutes ago. So what I'm saying is, in order to find area of the triangle, you need to find the length of this base and the height, right?
Right.
Because area of triangle is half base into height, no?
Yeah.
So don't lose sight of that. Don't forget about that. You have to find the difference between the x coordinates of A and B. So technically, what do you have to find? Beta minus alpha, right?
Right.
Because that is going to give you the length, no?
Yeah.
You have to find half into beta minus alpha times h, where h is this much, right?
Right.
So don't forget about that. You can try it out now. Try it out, see what you are getting.
No, please don't rub the question. Yes.
See, the hint is that because alpha beta are roots of the equation and A is alpha comma 0 and B is beta comma 0, I know that alpha plus beta is equal to what from the quadratic?
Uh, I'm getting a bit confused in that, so I actually went ahead and like used the like quadratic equation and solved for x and all that thing.
Right, but you should never be confused by Vieta's relations. You should know that alpha plus beta is minus B by A and alpha beta is C by A, right? Nobody has to be confused by these. In any quadratic, that is the case, no? So sum of roots and product of the roots.
Right.
So what is alpha plus beta if I put my in this quadratic, what will be minus B by A?
Uh, k minus 1
By
upon
1, so that's it, right?
yeah.
And product of the roots will be C by A, but notice that C comes with a negative sign and all, right? This
Right.
whole thing is C, right? So
Right.
it is minus K minus 1, right?
Yeah.
If we know the sum and product of alpha and beta, it is actually not very difficult to find this beta minus alpha. The reason is that we know identities, algebraic identities. Do you know that beta minus alpha whole square will be beta square plus alpha square minus 2 alpha beta?
Right. Yeah.
But we can always write this as beta square plus alpha square plus 2 alpha beta minus 4 alpha beta, right?
Yeah.
So isn't that equal to beta plus alpha whole square minus 4 alpha beta?
Yeah.
So we know beta minus alpha wholes, this is basic identity, that this can be written as this square minus 4 alpha beta, right?
Right.
If I already know alpha beta, alpha plus beta and alpha beta, I can directly find this, no, no. Do you
Uh,
understand? I can directly find this. What is beta plus alpha whole square? It will be k minus 1 whole square.
Yeah.
And minus 4 times alpha beta is what? Minus k minus 1. Correct?
Yeah.
So this part, if we simplify, it will be k square minus 2k plus 1. Minus 4 into minus k, so plus 4k and plus 4. So you will clearly get k square plus 2k plus 5, right?
Right.
We have gotten our beta minus alpha whole square. What we need is beta minus alpha, which will be root over k square plus 2k plus 5. Correct?
Okay.
Do you realize that we don't have to solve the equation for that? Solving the equation was unnecessary because Vieta's relation helps us get it.
Yeah.
Is it clear? Is there any problem with what we did?
No.
Right. Why did we need beta minus alpha? Because that was the base length of the triangle, right?
Yeah.
The only thing that is left to figure out is the height of the triangle, which is like the y value of c, no?
Right.
Because this is the x-axis, so wherever c is at minus b by 2a comma some y value, right? We just need that y value, right?
Yeah. Y
Okay,
value as in like the height.
the y coordinate of c, right?
Okay. Yeah.
That's the meaning of
So
height,
we
no?
can, yeah. So we can like add like put the minus
Yes,
b upon this into
into the
like,
function, right? We can just put minus b upon 2a into the function for x, right?
yeah.
So x value, actually first we'll have to write what is minus b upon 2a. So it will be minus of this b is negative. So it will be k minus 1 by 2, right?
Right.
That is the x value of the c point, right? Correct, no?
Yeah.
We'll put this into the expression to get the y value, which will become the height of this triangle, right?
Right.
Okay, so we'll put that into it and say k minus 1 whole square by 4 minus k minus 1 whole square by 2 minus k minus 1, right? These two will become minus of k minus 1 whole square by 4, and then there is a minus k minus 1. Do you understand?
Right.
You can take minus common from everything and you will get minus common k minus 1 whole square by 4 plus k plus 1, right?
Yeah.
And let's simplify it a little bit. Put 4 in the denominator plus 4k plus 4, and you will get k square minus 2k plus 1 plus 4k plus 4. So it will become k square plus 2k plus 5 divided by 4, and outside there is a minus sign, right?
Yeah.
So notice that it is okay that it had a minus sign because the minus sign is telling us that C point is below the x-axis, right?
Yeah.
If it was C point was minus 10, the y value, then actually the height is simply the 10 part of it, right?
Yeah.
So this
So it's
minus sign we
the,
can ignore, right?
yeah, it's just the k
It's just
square
this
minus
part, right?
2k. Yeah.
Yeah. So that is the height, and we already know root over k square plus 2k plus 5 is the length of the base, right?
Right.
So our area of the triangle is now coming out to be, in terms of the variable k, it comes out to be like this. area is equal to half into base into height. So half into 1 by 4, so 1 by 8, and it is k square plus 2k plus 5 multiplied by root over k square plus 2k plus 5, right?
Yeah.
Isn't that k square plus 2k plus 5 whole to the power 3 over 2, right?
Right.
This is power 1, this is power half, right? Now, if you
Yeah.
think about it, this part is, notice what is this? This is actually k square plus 2k plus 1 plus 4 to the power 3 by 2, right?
Right.
Why did I split it? Because this will make it a perfect square, right? Do you understand? K square plus 2k plus 1 is basically k plus 1 whole square.
Yeah.
So I can write it as half of 1 by 8 of k plus 1 whole square plus 4 to the power 3 by 2, right?
Right.
Okay. Now, think about it. We need to find the minimum value of this, right? The minimum value of this area, right?
Yeah.
The area will be minimum if I can minimize the stuff inside, right?
Yeah.
When will it be minimum? When this part is 0, no?
Okay.
See, k plus 1 whole square is always going to be positive or 0, right?
Yeah.
So the lowest value of this is what? 0, right? K plus 1 whole square.
Okay.
Any other value, if you put k equal to anything other than minus 1, this part will become positive, no?
Yeah.
So how can we minimize the value? Minimizing will happen when k is minus 1, right?
Right.
Do you understand what I'm saying?
Yeah.
If k is minus 1, the square is 0 and only 4 is left, right?
Yeah.
And in that case, it will be 1 by 8 into 4 to the power 3 by 2, right?
Right.
And 4 to the power 3 by 2 is simple because 4 is 2 square, right? So it will become 2 square to the power 3 by 2. So 2 and 2 will get cancelled. It will become 2 cube or 8, right?
Right. So it's 1.
So area is 1 in that case. Area is 1, which is the minimum possible area. And that happens when k is equal to minus 1, right?
Right.
If k is anything other than minus 1, the area will be bigger than 1. Correct?
Got it.
So basically in this problem, what we did was we had a situation like this. We had to figure out area of this triangle. What we did was realize that these are the two roots. Since these are the two roots, I need to find first of all beta minus alpha, right? Correct?
Right.
And I will not actually find the roots and then calculate beta minus alpha because that makes my calculations too much. What we did was we said that beta minus alpha whole square is equal to beta plus alpha whole square minus 4 times alpha beta, right?
Right.
This is an identity because we have learned identities in the previous classes, so you should know this, right?
Yeah.
And beta plus alpha was coming by Vieta's relation, and beta alpha was also coming by Vieta's relation. The advantage is that we didn't have to solve the quadratic for these, right?
Right.
So we just put that here and put this here, and we get beta minus alpha is equal to root over k square plus 2k plus 5. Correct?
Got it.
After that, it was about finding C point and what is the depth of this C point or the y coordinate, right?
Yeah.
So
The height.
C, the height. So it was at x is equal to minus b over 2a. And when we put that value into the function, we got something like negative root over k square, negative k square plus 2k plus 1 by 4, or 2k plus 5 by 4, or something like that, right?
Right.
We will not care about the negative sign because all we need is the length, not the whether it is above or below x-axis, right?
Yeah.
The negative sign is telling us that it is below, but it doesn't tell us length. Length is just this magnitude, right? And then we got area expression. Area expression came out to be like this: 1 by 8 k square plus 2k plus 5 to the power 3 by 2, right?
Right.
And here we have to find minimum value of this area. The way to think about it is realize that this thing can be written as a perfect square plus some constant. It is k plus 1 whole square plus 4, which is clearly going to be greater than equal to 0 plus 4, right?
Right.
Because this part is always going to be greater than equal to 0. If you want minimum, you have to make it 0, right?
Yeah.
So make it in 0, making it 0 happens at k is equal to minus 1, right?
Yeah.
And then the whole thing inside becomes 4, and it becomes 4 to the power 3 by 2, which is equal to 8, and 8 by 8 area is 1.
Okay.
Is it clear what concepts we have used and all here?
Yeah.
Okay, fine. Let's look at another problem. Right, 1 second. Okay, I'll write it here. You try it out. Question 3 is saying, suppose the graph of y is equal to x square plus ax plus 2 has two different common points with the line segment connecting m, which is 0 comma 1, and n, which is 2 comma 3. Find the possible values of a. So first of all, try to understand what the question means. When they say two different common points, do you understand what he means?
Give me a second. Like, they are both like
Like
having the
this.
same. Oh,
See, common points means, see, there is a graph which is a parabola,
intersection.
right?
Yeah,
Right,
an intersection with that
right.
line.
So there is a line which is connecting 2 points. The points are given 0 comma 1, 2 comma 3. Common point of the line segment and the parabola is the intersection. And the question has
Right.
said that there are two different intersections.
Yeah.
So that is what it means. We have to find the possible values of the A constant. By the way, do you know how to make the line equation when you have 2 points given to you?
As in like y equals to
Yeah,
mx
yeah,
plus.
exactly. You can make the line equation connecting these 2 points, no? Y is equal to mx plus c.
Yeah, so like gradient formula and
Yeah.
then
So make the line equation first, then only you can do anything. Because actually it's the intersection of this equation and this equation, right?
yeah.
Right.
It's 1x plus 1.
Hmm. This is the line, right?
Yeah, x plus 1, yeah.
Y is equal to x plus 1 is my line. And 2 points on the line were M and N. Notice that x value here is 0 and x value here is 2, right?
Right,
And between x goes from 0 to x goes to 2, the parabola and the line were intersecting at 2 points, right?
right.
Let's call them P and Q. And based on this information, we have to find out our possible values of A. Remember that our x values of the line are varying from x belongs to 0 to 2, right?
Right,
Right. So obviously it will be the same. The x on the parabola here also will be between 0 and 2, right? It's on the line segment between the M and N.
right.
Hmm. So now think about it, what we can do then. If they are points of intersection, then
Why can't we like use the M point in y equals to x squared plus that equation?
because they have not said that the M point is lying on the parabola, they have said that it's lying on the line. Did they say it's
No, have two different common points, like they are not intersecting.
line segment connecting M and N? Did they say that M and N is on the parabola?
Okay.
Nothing has been said that M and N lie on the parabola, no. They said that there are two
No, it
common
has two
points.
different common points. Yeah. Yeah, so that is the intersection, no? So they do
No,
lie on it.
no, they don't. Read the question carefully. You are assuming too much. If there
Common
is a
points would mean intersection only, no?
yes, but it's not M and N that are the intersection. M and N is telling you that it's the line segment connecting M and N.
Oh, okay, okay. Okay, yeah, my bad.
M and N is not being said that M and N lie on the parabola. There could be common points, but doesn't have to be M and N. If they tell you that M and N
Right,
lies on the parabola, then there is no question left.
right, yeah.
Then automatically you will get
Can
everything
we
that the
equate both like equations
yes,
and
obviously.
try something?
There is no other way to do anything. You have to equate to find P and Q, you have to equate this and this, right?
Right,
Because P and Q lie on both the things, right?
Right.
You are saying that the y coordinate of the parabola is same as the y coordinate of the line. Correct?
Right.
Do you understand what we are doing here by equating?
Yeah.
Notice that this equation gives you a quadratic equation, right?
Right.
Equating both of them leads to a quadratic, and this quadratic should have two roots. Why? Because they said that there are two different points of intersection, right? P and Q.
Yeah.
If one of the roots will be, let's say, x1 comma y1, one of the roots will be x2 comma y2. That is, the solutions of this equation should be x1 and x2, no, two different points, right?
Okay.
You don't understand what I'm saying?
Like, how does this guarantee two roots? Like,
Suppose you have a parabola like this, x square plus 3x plus 2. And suppose, okay, I will just take a simpler parabola. Uh, this is my parabola, y is equal to x square.
yeah.
This is the simplest possible parabola. This is y-axis, this is x-axis. Now, I will take a random line, y is equal to x plus 2. And I will say that this line intersects the parabola at 2 points. Find the points. Do you understand the question?
Yeah.
So now if you think about it, the line is like this, something like this. Y is equal to x plus 2. Now, this, when x is 0, y is 2. This is one of the points on the line, by the way, right?
Yeah.
If I want to find the point of intersection, I will take the equation of the line and take the equation of the curve, and I will equate them, basically saying y is same. But y is same is happening, isn't it happening at two different points?
Right.
See, this is a point A, this is a point B. Here the line and the parabola both meet, right? Correct?
Right.
If I equate the y, so basically what does it mean? When they are both meeting means x and y are both same, no? On the
Yeah.
line, whatever is the x and y of this point is the same as the x and y on this, right?
Yeah.
So what are we doing? When we equate them, what happens? X square is equal to x plus 2, right?
Yeah.
But when I make it a quadratic like this, it is guaranteed that it has to have two different roots. Because if it didn't have two different roots, what about the B point?
Oh, yeah. Okay.
This has to have two different solutions, no? Then only you'll get a x1 comma y1 here and a x2 comma y2 here, right?
Right.
If it had only one root, then how can you get two different points? Do you
Right.
understand what I'm saying? This
Yeah.
solution will be x square minus 2x plus x minus 2, x common x minus 2 plus 1 common x minus 2. So x plus 1 into x minus 2. And we are getting x is minus 1 and x is 2. So we are getting two different points coming from equating the two equations, line and parabola, right? If you put x is equal to minus 1, one of the points is coming as minus 1 comma 1. if you put x is equal to 2, the other point is coming as 2 comma 4. Can you see that both of these lie on the parabola also?
Right.
Do you understand why we are getting two different roots?
Yeah.
Because there are supposed to be two different points of intersection, right?
Yeah.
So in our problem, when the question was, our parabola was slightly different, y is equal to x square plus ax plus 2. Our line was y is equal to x plus 1, and x was going from 0 to 2 because m and n points were given. They were 0 comma 1 and n was 2 comma 3. From here, m and n only we found the line equation, right?
Right.
But now we have to think about the intersection of these two. So the question has already told us that there are 2 points of intersection. Correct?
Right.
So when I equate them, I am getting a quadratic x square plus ax plus 2 is equal to x plus 1. I'm getting x square plus a minus 1 x plus 1 equals 0, right?
Yeah.
But is it possible for this equation to have no roots or only one root? It is not possible. It has to have two roots because the question has said there are 2 points of intersection, right?
Right.
Do you understand what I'm saying right now?
Yeah.
When you equate the line and the curve, the equation should give you the 2 points A and B, right? Which are the solutions.
Yeah.
So once you know that, we can use our knowledge of quadratic equations to say that, first of all, if this equation has two roots, the discriminant should be greater than 0.
Yeah.
Do you understand?
Yeah.
Okay, so from there, what can we say? Discriminant is a minus 1 whole square minus 4 times 1, right?
Yeah.
So we are getting a minus 1 whole square should be greater than 4. And that can happen when a minus 1 is greater than 2 or a minus 1 is less than minus 2, right?
Yeah.
So from here we are getting a is greater than 3 or a is less than minus 1. Correct?
Yeah.
Okay, so that is the first thing that we have realized, right? This tells us something about a, right?
Yeah.
But our job is not
Like
done.
a range.
This gives us some range of a, but it's not over yet because we have to figure out some other stuff also. So remember that the line segment MN was from 0 to 2. X was varying from 0 to 2, right?
Right.
Because see, x coordinate of M is 0 and x coordinate of N is 2, right?
Right.
So the points A and B should be such that they will lie between 0 and 2, no, x coordinate,
Okay. Yeah.
right? So we
Yeah.
can say one more thing, that the vertex of our parabola should be between 0 and 2. Vertex is somewhere here, no?
Yeah.
Our x coordinate here is 0, our x coordinate here is 2. So this vertex is at x is equal to minus b by 2a, should be between 0 and 2, right?
Yeah.
But the parabola is this parabola. The equation is this equation, quadratic equation. So this quadratic's vertex lies between 0 and 2, right?
Right.
Okay. So what can we say from there? So notice that the vertex is at minus a minus 1 over 2 That is the point at which minus b by 2a for this. And it should be between 0 and 2. Correct?
Right.
Multiply by 2 both sides. 0 is less than 1 minus a is less than 4. And you get minus 1 is less than minus a is less than 3. Multiply by minus 1, you get 1 is greater than a is greater than minus 3. Right?
Right.
We are reversing the inequality because we have multiplied by negative quantity.
Yeah.
So we are getting another thing that, okay, so far what we have gotten? We got a is greater than 3, a is less than minus 1, and now we are getting a is greater than minus 3. Minus 3 is here, so it should be greater than minus 3, and it should be less than 1. So then we can ignore this part, right? A greater than 3 and all, right?
Yeah.
Because it should be less than 1, right?
Right.
So far we have gotten a is from minus 3 to minus 1 only, right?
Yeah.
Do you understand how we are intersecting all the cases, right?
Yeah.
Okay, so minus 3 to minus 1. We can also say that the y values of y value of m was 1 and y value of, one second, let me think. F of 0, right? uh, yeah, I think that's about it for now. We have gotten mn line segment like this. We had a parabola like this, and we said that this was 0 comma 1, this was 2 comma 3. We found the range of values of a by doing discriminant is greater than 0, and we also said that the vertex here x is equal to minus b by 2a lies between 0 and 2, because x coordinate lies between 0 and 2. I think that is sufficient. We have already gotten one condition on a from here, and we got one condition on a from here, right?
Right.
We got two different conditions on a, and from there on the number line we can realize that a should be between minus 3 and minus 1. Correct?
Right.
So that is what they are asking us to find, the range of possible values of a. Do you understand what we were doing here? The
Yeah.
main thing is to realize that when you intersect a line and a curve, when you equate them, the solutions of that resulting equation gives you the point of intersection, right? Different points of intersection will come by solving that equation that happens. Is it clear?
Yeah.
Okay, fine. What I will do is I will make a small assignment for you to try till Friday, till Saturday. That assignment will be on quadratic equations only, and it will not be super difficult or something, but you have to try it out. Okay. If you get stuck, don't worry about it. We'll discuss it. Okay. I'll share the assignment by tomorrow latest, and you need to try it out. Can you hear me?
Yeah, yeah, I can.
Okay. And also
Hello.
get that test of mathematics book. Okay.
Okay, yes.
If you search for it on Amazon, you will get it. Test of mathematics as 10+2 level. That book will
Right.
be useful for us because then we can do assignments from there. It has chapter wise questions. So then you can practice from there itself. Okay. So order that book and work on the assignment that I will share. And we will discuss the solutions and we'll discuss what you have tried on Saturday's class. For quadratic equations, we'll possibly do at least 2 more sessions. So then more or less it should be done. Or 2, 3 more classes for sure we'll do. We'll do different types of problems and see what we can
Can
learn
we
from it.
mainly do problems at home? Go ahead with a concept or chapters and all.
What do you mean?
As in after we have finished with the theories and all, right?
Hmm.
So can you give the questions at home for me to try first, and then if I have doubts, then we can do it in class.
Right, that is what we'll do. But today's class I needed to revise the theory, otherwise I don't know whether you've forgotten it or not. That is
Yeah,
what
no,
the
this is
usual
fine.
plan is. Usually it will be like you have to try at home and we'll discuss the doubts in class.
Right. So 2, 3 will be required for only quadratics.
2, 3
Like
classes.
yeah,
Yes, it will probably be more than that.
but just solving questions.
Yes. Right now you have not done many types of problems. You're not very good at it right now. Once you get the book and you see the questions in the book, you will realize what you have to do. So far, you have not seen any textbook, no? Any book from where quadratic equation questions are there.
Yeah.
So right now, you have not even scratched the surface. You're just at the beginning right now. See,
Right.
it is very easy to go ahead in the theory and keep doing theory, many new things. But it is not going to be useful for you unless you are also getting to solve problems and getting better at solving problems.
Right. Got it.
The more theory you do, the more types of problems you have to tackle. So 2, 3 classes I am saying is a minimum number, at
Okay.
least. There is no rush, okay? You don't have to rush through the theory. The point is to be able to solve problems. Ultimately, you have to learn problem solving. It's not about the theory. Theory, or anyway, they will teach you in school and all.
No, we don't have so much of this in school. Like
Forget school
ours is
anyway.
nothing compared
Yeah,
to.
yeah, forget school. But see, that's why I'm telling you, not get that book that has ISI-CMI type of questions. When
Right.
you see the questions, then you will realize, ki, okay, this is the level that I have to reach. Then you will be asking for more classes on quadratics. Right now, we are just
Right.
starting out. Don't worry about the timelines and all so much. Once 1 or 2 chapters become strong, after that, everything will seem easy. That's the main thing. Once you get strong at 1 or 2 things, then everything seems easy. But it will never be done if we keep doing new theory and not do enough problems. Do you understand what I'm saying?
Yes. Okay.
Avoiding problem solving is never the solution. So right now I'll give you an assignment. It will not be very big or something, but it will have some good questions. But you need to get this book ASAP because it has chapter wise questions, and then we can easily say ki, try exercise 1 of that chapter. We can easily do the work from here. Okay.
Right.
So Don't worry about it. Just keep doing what I'm saying. And once you have the relevant textbooks, we'll work from there. And then you will see what is required. Okay, I'll send the problem
Okay.
set by tomorrow for sure. Tomorrow morning or sometime. After that, you can start trying it. Okay,
Okay.
fine. That's all for now then.
Thank you, sir. Bye.
Bye.